Hello everyone, my name is Rohit Jafari and I would like to welcome you to another video. In this video, we are going to talk about hierarchical clustering. Hierarchical clustering is a very simple clustering algorithm that in some specific examples, and if you know how to use its different methods, can be a very effective clustering algorithm. However, hierarchical clustering has a few meaningful disadvantages that at the end of this video we're going to learn about. Alright, let's look at this slide. Okay, so in this video we are going to first do some recap about clustering. We have talked about clustering before, but just a quick recap what's clustering, and then we are going to sort of see a distinction between two types of clusterings, hierarchical and partitioning. And within hierarchical clusterings, there are also two types of hierarchical clustering. We're going to see the difference between these two, which are called agglomerative and divisive. And also within agglomerative hierarchical clustering, which we're going to discuss in further detail, there are a few different methods of connecting the clusters, and we're going to discuss them. Of course, we're going to look at an example, and within that example we're going to see how the results of hierarchical clusterings are going to look like. Alright, so we did discuss what's clustering. Clustering is when we have no dependent attributes. All we don't have a supervised agenda. Our agenda is unsupervised. We want to basically, based on the attributes in the data that are important for us, see if there is patterns that are existing in the data, and these patterns are caught by just seeing if there are data objects that naturally are more similar to one another, and there are data objects that are naturally more different than to one another. So in clustering, we try to create groups of data objects that are similar to one another, and these data objects that are grouped together are very different than the rest of the population and or the other clusters. So that's the agenda in clustering. And you can see here we don't have a dependent attribute try to predict or classify, and that's why we call this agenda an unsupervised one. So we saw this example of 122 countries, and we were trying to cluster them using two attributes. We had perception of corruption and life ladder, and when we have only two attributes or two dimensions, we could go about the task of clustering using a visualization, right? But as we discussed, in a lot of cases we don't have just two dimensions, and because of that we're going to need algorithmic approaches in how we would go about clustering. So that's the reason that we have partitioning clusterings, hierarchical clustering, and so on and so forth. So there are four types of clusterings. Like sort of the way they go about clusterings are different. During our videos we're going to discuss these two, hierarchical methods and partitioning methods. And in this specific video, we're going to talk about hierarchical methods, and we're going to see a little bit of what is partitioning and the difference between hierarchical and partitioning. So a hierarchical method is in a specific way of going about finding the groups that are similar in the data. I mean, that's basically what it is. You just go about it in a very specific way, and that specific way is basically sort of one step at a time, trying to create these clusters. I mean, in one way of doing the hierarchical clustering is all of the data objects. As you can see here, there are all of a group for themselves, and then one by one you decide to connect these sort of data objects together, and as you move further down the line, these connections come together, and you have data objects, you have clusters with more data objects, and eventually you get to a state that all of your data objects are one cluster, right? So you can see here as well, this is called a dendrogram, right? So this is called a dendrogram, And you can see first we connected A and B, and then D and E, and then we connected C to that cluster of A and B, and so on and so forth. We create this cluster level by level. So that's why it's called hierarchical. There are two types of hierarchical. One is agglomerative. You start from the all of the data objects being their own clusters, and you will end up with one cluster, and that's called agglomerative. On the other way of it, we've got divisive, which you start all of the data objects in the same cluster, and you start splitting these data objects to get into a state that all of the data objects are on own clusters. So there are two different approaches in this hierarchical clustering. The one that we saw in the previous slide was agglomerative, of course. In this video, we're going to focus on agglomerative. So this is the difference between divisive and agglomerative. As you can see, on agglomerative, things start to come together. On divisive, we start to sort of like separate the data until all of those data are of their own clusters. So now we talk a little bit about partitioning methods. We quickly will snap back to hierarchical, because this is a video hierarchical. It's just to see sort of like the distinction between the two. With partitioning clustering, we have one level clusterings, and the k-means that we used to discuss in the other videos when we talked about clustering is a partitioning method. I mean, in partitioning method, you say I want to cluster my data into k, or like however many groups, and then using an algorithm that can do that for you, just basically separate these data objects, and that's called a partitioning method. K-means, which is the most famous clustering algorithm, is also partitioning. And this is the difference between them. For hierarchical, you have levels of clustering. For partitioning, you have that one level of clustering. Like, you've got 4 clusters here, you've got 3 clusters, and that's about it. That's the difference between partitioning and hierarchical. So now let's talk about different linkage methods that the agglomerative clustering and hierarchical clustering uses. So we've got single, complete, centroid, average, and wards. Within these examples, you understand what we mean by linkage. So imagine that some level during our clustering, we want to sort of see the difference between the distance between two clusters, right? If we had only two data, a few data objects, right, that they had not been connected to one another, we've got Euclidean distance. We know the distance between these objects, between these objects, right? We can use a Euclidean distance to easily see the distance between any two data objects. But how about when we've got clusters, right? If you remember, in the process of doing clustering with hierarchical, there are times that we have to see the distance between a data object to a cluster, or the distance between two clusters, right? We want to see the distance between these two clusters, so we can select the best first connection, right? So because of that, we have to sort of know how we would go about, sort of like defining this agreement. How do we calculate the distance between two clusters, right? I mean, there are different ways or different approach here, and by changing these approaches, the results will also be very different, right? So with the single linkage, what we say is that are the distance between two clusters are basically the smallest distance that any members of these two clusters can have from one another. So so in this example, this would be the single linkage, right? So because this is the closest one and this is the closest one from this other cluster, then we use this distance to sort of like measure the distance between these two clusters, right? Then with complete distance, we do the opposite. We say, okay, we're going to sort of like agree upon two clusters distance, or the distance from one another is the maximum possible distance that they can have, the data objects in these two clusters that they can have from one another. So in this example, probably this would be the complete linkage. And then we get to centroid linkage. Centroid linkage is, basically you find the centroid of each cluster. These are the centroid, and then you calculate the distance between these centroid, right? So this is the centroid linkage. That we sort of like agree that the way we calculate the distance between the two clusters is this way. And then we've got average linkage. With average linkage, we basically get the distance of every member of the clusters from one another. These two clusters from one another. So for example, here we've got all these distances, right? So we calculate all of these distances. 3 here, and then we've got 4 here. We've got 12 connections here, right? So we calculate all of these connections and divide them by 12, and then that would give us the average linkage. And then we've got wards linkage. Wards linkage is a little bit tricky to understand. So let me try to explain it here. With ward linkage, what you do, you basically assume that you have formed the cluster, right? You say, okay, what if I already formed this cluster, right? And ward linkage says, okay, now that I have formed this cluster, I'm going to have a centroid here, right? So if this is my centroid, how much information do I lose by sort of like re-representing all of these 7 data objects with one new data object, which is this cluster, right? So it calculates the distance of all of the data objects from this centroid, right? And it calls them errors, and it calculates the sum of squared errors, right? So it calls these values errors, and it calculates the sum of squares error, SSE, for this. And it uses this as a sort of like a distance between these two data objects, between these two clusters, right? So this might not sort of like intuitively make sense, but it makes sense once you look at it in the existence of other possible clusters. So let's assume we want to select the the next 2 clusters to come together. This is the space of our data objects. We've already clustered these 4 clusters. Next, we want to find which one of these 2 clusters should merge, right? This is hierarchical clustering. So the way the wards linkage would work, it would sort of assume each of these sort of like data, each of these clusters have joined together once, right? They have formed that cluster, right? So it joined these once, and it gets an SSE for them, right? And then it joined these, right? It gets an SSE for them. In the same way, it would get an SSE for them. All right, so now that we've had all of these sort of like SSEs for all of these possible clusters, bigger clusters, now we can say the one that has smaller SSE is the best next merging of these clusters, right? So now this makes sense, because we are trying to find a distance. This is a distance, SSE in itself, and one of the sort of advantages of this way of going about this SSE, right? We sort of calculate this SSE, right? But with this, we could calculate any functions that we're going to think it's important. SSE is a really good function. It calculates the loss of information if we were to re-represent all of these data objects that are coming together with this clustering, right? So this is a really good formula to sort of capture this, and it works for clustering. But the thing is, you can now be a little bit creative and have different objective functions here, or formulas that would capture this. This is just sort of for the next step thoughts that you can actually have your own linkage method here. All right, so now let's look at an example. So this is the example that we use for when we moved from 2D to 9D. Right here, we've got 9 dimensions, and they are And now, for us to be able to cluster these countries, now we have to use methods that are not visual, because we are not going to be able to handle this visually. So if we were to use hierarchical single linkage, this would be our clustering result, right? And you can see, when we move from single linkage to complete linkage, it looks like a complete revolution. I mean, the whole thing changes by just looking at the way we would calculate distance between clusters. And if you pay attention to the difference between these, we've got sort of like two colors here, but we've got 3 colors here. And on complete linkage, we actually sort of see clusters, right? I mean, we see a cluster here, right? We've got a cluster here, we've got a cluster here, and we've got a cluster here, right? So it changes the whole dynamic of the clustering results when we move from single linkage to complete linkage, right? One thing that this software or this module have created these dendrogram with, or have created these hierarchical clusterings with, is that once there are sort of like natural clusters that comes out of these dendrogram, it basically changes the colors for them. So they are known as different clusters. So we can see them as different clusters. And to do that, what it does, it basically puts a line, cutoff line here, and that cutoff line sort of like tells us that these are the clusters that we want. Let's move to the next linkage method. We've got centroid, and it also sort of changes the way our clusterings look like. And then we've got average linkage, again changes, and then we've got wards method, and this is also very different. We can see that the complete method, complete linkage, and wards method linkage, these are the ones that actually created natural clusters for us. I mean, for example, here I can have an alternative cutoff with the ones that the module automatically decided for me. But by looking at the dendrogram, we see I actually have opportunity to have 1, 2, 3, 4, 5, 6, 7 meaningful clusters that's coming out of the hierarchical clustering. By changing this, that cutoff that the algorithm decided for me, I'm changing it to a new one, and this one sort of gives me these clusterings that are meaningful. All right, the hierarchical clusterings have 2 weaknesses, 2 meaningful weaknesses that stands in your way when you want to apply hierarchical clustering. One of them is that, as we saw, it widely changes, widely swings when you have different methods of linkage. And of course, the best way to decide which linkage works best for you by experimenting. And also, sometimes if you add one new data objects, if we were to add one new data object to these, each of these each of these methods of hierarchical methods, the result will be very different. I mean, it's not a very sustainable way of doing clustering, because by just one data object, the whole result will be very different. Another thing is, it can be very computationally expensive, especially with the more involved and more scalable linkage methods, such as the wards method that we saw. It gave us more natural clustering out of our data. Alright, so in this video we talked about the hierarchical clusterings. We did see the difference between hierarchical and partitioning. We also talked about 2 ways of going about hierarchical clustering, agglomerative and divisive, and also we talked about the different linkage methods, and we saw an example, and we saw the results of different linkage methods of agglomerative clusterings on these on the data set. We also talked about the weaknesses of the hierarchical clusterings. Alright, until the next video.